Hi, my name is Yohan Yu, and this is a video for STA 210 Exam 1 Part 2. Exhibit 1, Question A. Using information only in the paragraph above, what is wrong with the scientist's claim? What is the specific name of the type slippery evidence present? Okay, it is wrong because the scientist came up with wrong data. As you can see, one day has 1,440 minutes. So 1,440 times 365 times 120, we get around 63 million, not 600 million. So I can say that scientist's claim is wrong because he made a wrong calculation. And the specific name for the slippery evidence is called misplaced decimal because there was a mathematical error. Question B. Describe how slippery evidence can interfere with human inference. Use the scientist as an example. We know that slippery evidence causes initial human inference, but it is often turned out to be wrong because it is not analyzed first. So when I first read the paragraph, I thought the information was right. But after I did the calculation with further reviews, I made my own inference, which is now considered to be correct. So the slippery evidence without any review can cause false information. Question 3. Using information only in the article, explain why the scientist cannot claim that fast food causes heart disease. Okay, fast food and heart disease are associated with one another, but it is a bit difficult to say that fast food directly causes heart disease because there are many other factors that actually cause and affect heart disease, such as smoking and unhealthy diet pattern. So I can say that scientists cannot claim it. Exhibit 2. Question A. What is correlation and how does it differ from causation? Okay, I'll first define correlation. Correlation is the measure of straight line association, and it shows how variables are associated with one another. However, it differs from causation because causation is about one variable directly affects another variable, causes another variable. And if there is a causation, then there is a correlation. But even though there is a correlation, we do not always have causation. Question B. What is the correlation coefficient? Use 3 pictures to help with your answer. Okay, correlation coefficient is a common numerical value of straight line association between -1 and 1. And there are 3 types. We have positive, negative, and zero correlation. For positive, here's a picture of positive correlation. As you can see, the scatter plot goes upward to the right. And correlation coefficient for this is R1. And here's a picture of negative correlation. And as you can see, the scatter plot goes downward to the right. And the correlation coefficient for this is -1. R minus 1. Lastly, we have zero correlation, and as you can see, all the plots are mixed up. And this means then there is no relationship between two variables. When the numerical value between two variables get closer to -1 or 1, we say that two variables have a strong relationship. But when the numerical value gets closer to 0, we say that two variables have a weak relationship. Question C. Give an example of two variables that are associated but have no causal relationship at all. Okay, there are two variables that are associated but have no causal relationship. They are studying and academic grades. Of course, if you study a lot, you will get a good grades. But actually, there are many other factors that affect school grades, such as psychological condition, or whether you had a breakfast or not, or how much you actually concentrated on it. So I can say that studying and academic grades are the variables that are associated but have no causal relationship. Question D. Give an example of two variables that are associated and do have a clear causal relationship. There are two variables and they are exercising and building muscles. People say that eating protein will help you build muscles, but actually it's not helpful. You actually need to give masses to your muscles to increase your muscle strength. So these variables are associated and have causal relationship, because simply if you exercise, you'll get muscles, but if you don't exercise, you do not get any muscle. Lastly, question E. An explanation of why we are studying this as part of our slippery evidence. Okay, we are studying this because when we study the relationship between two variables, there's often a third variable called lurking variable, and this changes the response to a treatment. Also called confounding variable, this causes confusion to our inference and confusion between two variables. So we really need to study this to make sure that we are having correct data. We usually have our first inference based on slippery evidence, but the slippery evidence can actually cause incorrect human inference. So in the field of statistics, if we do not try to find lurking variable, then the information we discover cannot be 100% correct, even though it still makes sense.